Okay, I think most people are done. Let's go ahead and take a look. I think I have a... So you should have this, right? 5, 7, 9, and 4 as your frequencies, and then your relative frequencies. And you might have written them in different order than that, but if you wrote them in A, B, O, and A, B, then your relative frequencies would be 0.20, 0.28, 0.36, and 0.16. 3 decimal places is good, but since these only, they choose 5. I mean, if it rounds up usually like this, and choose 5. Okay. So now we're going to talk a little bit about frequency distributions. It's used when the range of the data is large. You put them into classes, right? And classes should be the same size, but occasionally they might be open-ended on the top or the bottom. By open-ended, this is what I mean right here. You guys see how we have classes, and they're all 15 people in each class, but then at the bottom it's 70 and above. That's open-ended. That's what I mean by open-ended. When it goes 70 and it goes on and on forever, right? 70 and up. How you decide to split them into groups. So this is according to the book. This is your textbook's way. First, decide how many classes you want. Then figure out your range. Range is when you find out, you take your largest and your smallest and you subtract them. That's your range. Then you take that range and you divide by the number of classes you want. And then you make sure, and then you round up to the next integer. Why do you round up? Because you want to make sure that you have, you have kind of more room than less to make sure you put all your data. If you round it down, you would not input all your data. So that's why you have to make sure you round up. So let me ask you a question. If I say read pages 10 through 20, reading pages 10 through 20, how many pages have you read? 11, 10, which one is it?
10.
10 through 20, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. It's 11, right? Pages 10 through 20, including 20. So that's why you have to round up, because you need to kind of take it out. When you do range and you just subtract them, you're kind of leaving out one spot. You actually have one less spot than you think you have. So that's why you kind of have to make sure you round up. All right, let me show you an example. All right, so for example, say I have a bunch of weights of rats. Doesn't matter whether I have 5 rats or 500 rats. All that matters is the range of the weights, so I make sure I cover all of them. So the smallest rat is 8 ounces. Largest rat is 20 ounces. What's my range? What's the range?
13.
18. So again, range is the highest number minus the smallest number. So 12. So my range is 12. How many classes do you want? How many classes do you want? Someone tell me how many classes you want.
4.
Has to be 5, at least 5. 5 to 20. 6. Okay, great. 6. All right, so my range is 12. I want 6 classes. All right, good. So I take 12. I divide by 6, the number of classes I want, and I get 2. You have to round up from 2 to 3, and I'll show you why. If I don't, if I just take 2, and I start with 8 ounces, right? So 8 and 9. So 2 in each class. So 8 and 9 in the first class, 10 and 11 in the next class, 12 and 13 in the next class, 14 and 15 in the next class, 16 and 17 in the next class, 18 to 19 in the next class. I have my 6 classes, and there's nowhere for the 20-ounce rat to go. There's no spot for him. Because of this whole 10 to 20 pages is 11 pages, not 10 pages. That's why. So that's why you have to round up. So if you round up, or you can add one more class. You can do either one, really, right? Because you're controlling a situation. But you'd have to round. You'd have to go up to 3. So you'd go 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. And then that's kind of weird because then all of a sudden you have no room, 23, 24, 25. Kind of have nothing in the last class. So you might want to rethink and maybe do 7 classes. In real life, you probably would either do 7 classes, or you do 5 classes and stop it at at 22. Yeah.
So it doesn't matter how many classes you have; just has to be more than.
Yeah, it has to be more than 5. It has to be 5 or more. At least 5 classes, no more than 20. Yeah. Yeah, good question. Thanks. All right, but here's the deal. That's how your book has you calculate class width. And if your class is, if you have a small range, like that we did in the last problem, totally makes sense, right, to do it that way. But if your range is larger, like 25 or more, then my friend Jim Hannon is this great guy. He did statistics at Lawrence Livermore Lab for decades. Like he's semi-famous in the area. Like people know who he is. So he's a real statistician. He's done statistics, all his life. He actually does a little bit of volunteer now, like tutoring and stuff like that in our concurrent support classes. But he and I argued all the time because he's like, the point of showing data is to make it more readable, to make it more understandable, to get your point across in whatever presentation you're trying to do. So he's saying, what you should try to do is if your range is 25 or more, then make class with 5. Because everybody counts in 5s, right? Even small children can count in 5s, right? 5, 10, 15, 20, right? If your range is 45 or more, then have a class width of 10, right? And I went back and forth because I was like, yeah, but the book says do it this way. He's like, yeah, but this is how the real world does it. This makes more sense. I'm like, yeah, but the textbook says this. So for 2 years, we went back and forth on this, and finally he won, right? Because it makes sense, right? What he's doing is what people do in the real world, and it makes a lot more sense. So most of what we're going to do in this class is doing just that. When the range is at least 25, 25-ish or more, we're just going to do a 5 or 10 as our class width. You'll get more comfortable as we go through that. But before we get into that, let me talk about the parts of a frequency table. So I know this is kind of weird, like I didn't follow that rule. But wouldn't it have been a lot clearer if I'd done like 0 through 49 and 50 to 99 and 100 to 149? Would have been like clearer, right? All right. Anyway, right now we're just going to talk about the parts of a table. So that's all moved. All right. So here are my 6 classes. These things here are my lower and upper class limits. So in other words, they are the smallest and largest a data value can be and still be in that class. So like for this class, the smallest I can have the data value could be in that class is 244. The largest it could be is 304. These are the class limits. These are actual data values can be these numbers. Good? Class boundaries, right? You guys are familiar with boundaries. We did boundaries last class, yesterday, right? Boundaries are the numbers that are smack dab between 2 classes. So here I have a class 0 to 60. I have another class 61 to 121, and I have another class 122 to 182. The boundary between them, well, the boundary between these classes is a number smack dab between these 2 classes. The number smack dab between 60 and 61. Does that make sense for folks? So what's the number between 60 and 61? 60.5. Good? So 60.5, it's this class's upper boundary, this class's lower boundary. And again, remember, boundaries have one more decimal place than our original data is in. So you can just take the lower one, the lower number, and just add a 5 into the next decimal place. So 60.5. Good. So this one here would be 121.5, would be that boundary there. Okay, so that's all well and good if you are creating classes and creating boundaries. But what if there's already a distribution table? You didn't make it, someone else made it. The table's already there. Now we're doing the opposite. You aren't making a table, someone else has already made the table, and you're just looking at their table. You can find the class width that they used the following way. Take two consecutive classes, two classes in a row, and you can either subtract their lower class boundaries or their upper class their lower class limits, their upper class limits, their lower class boundaries, or their upper class boundaries, and you'll get the same thing. You'll get the class width every time. I'll prove it to you. So here are my lower class limits, right? 122 minus 61 is 61. I'll take the upper boundaries, upper limits. 182 minus 121, I also get 61. Well, what about the boundaries? I take the lower boundaries. 121.5 minus 60.5. Again, you get 61. So two classes, consecutive classes, are separated by class width. You can either subtract their lower boundary, their lower limits, their upper limits, or their lower boundaries, or their upper boundaries. Is that making sense, folks? So that's how you find the width. You take two consecutive classes and you find the distance between them. Now, the other thing we're looking at is class midpoint. The midpoint, all right, so midpoints. Anytime you have the word mid, midpoint, mid-range, any of the mids. Mid means the middle, so you're going to average. You're going to take the top one, the biggest one, and the smallest one, and you're going to average them. So midpoint, you're going to take the largest value of the class and the smallest value of the class, and you're going to average them. You're going to find the middle, right? So here I'm going to take 121 plus 61, divide by 2 because there's two of them, I'll get 91. So the midpoint here is 91. For the next one, 122 plus 182 divided by 2, I'll get 152. But here's the thing. These are two consecutive classes. If I take their midpoints and subtract them, what do I get? The class width, 61. So once you get the first one, you can just cheat and just add the class width and get the next ones. Does that make sense? Yeah. All right. Yeah.
Then number 2, you got them because you got two classes, right?
Yeah, I have more classes. So I'll have like 6 classes. I can just add another 61 to get the next one, 61 to get the next one, 61 to get the next one.
Okay.
Yeah. All right, so now you should be able to answer I think, everything on your front of your page, the first page. So I want you guys to take a minute and do that with your neighbors. Find the lab words. Go ahead. So go ahead and do that. And then we'll take a break.